Okay, so in this video clip, I'm going to take a look again at the Boston HDMA dataset, and we're going to do a little bit of machine learning, or use machine learning algorithms from some some of these R packages. So we're going to use two packages. We're going to load in the library esat.dat, and that contains the HDMA Boston dataset, which was previously used by set out by Halvarian in his paper Big Data New Tricks for Econometrics. And we'll load in also here the library for party. Okay, so if you don't have those already installed, you need to install them. You can install them over here. Just put in party. Now, as it turns out, I already have that installed, but you can use it here by just putting in PARTY, and there's party and party kit. Party kit is a kind of an update on this existing party, but okay, I'm going to go with party. So the data set is HDMA. I pulled that in from the ESAT, the library. We're going to take just where all the cases are complete. So if we look here at all, which we've made the new object, the difference between the two data sets is that the HDMA has an extra row, but there's some NA here, and otherwise I don't think they exist. So if I reorganize these, I don't see NA appearing again. So it removes those rows with NA. I think there's only one. That's why when we go to all, we drop back one. So again, it's an identical data set, but we just deleted one of the entries that had NA in a couple of the cells. Okay, and as I also follow the convention set out by Halvarian, changed the name to Condo. So if we just come to HDMA, you can see it's been changed. Okay, just the name of the column. Okay, so let's just go back into our file here. Okay, we want to predict LVR, so the loan value ratio, and we want to use machine learning to somehow illustrate that under a different set of decisions we arrive at different outcomes, and we want to determine to what extent, or just see is there any evidence suggests here that LVR, the loan to value ratio, is somehow different for particular racial groups. We already have, if we go into the data, we can observe that we have a category here set up for black, either no or yes. And in the previous video clips where we looked at predicting mortgage approval, deny, yes or no, we found that black was marginally relevant, again depending a little bit how you set up the analysis. Here we're going to take a look at, can we predict outcomes for loan to value ratios and see what factors are influential there, and also examine, is there a particular loan to value ratio that applies for people who are designated as black as opposed to being not black, and if so, perhaps then that's evidence of some kind of segregation or bias in the decision-making process linked to mortgage origination. So initially here I'm just going to run a model, a C3, as we've done before, where we make, instead of mortgage approved yes or no, or mortgage denied yes or no, we're going to here set up the LVR as the dependent variable, and then we're going to see what comes out of this conditional inference tree type analysis. Now we're using all the data, which is probably probably not the way we want to approach this, because actually we just want to look at individuals who had their mortgage approved. But we start off where we include the entire data set. Okay, so let's just run that and then just do a plot, and maybe we can zoom here. And again, this is a little bit different from the previous conditional inference tree, because it was yes or no. We had black bar straddling across the bucket, and then the proportion of or probability outcomes we could measure by the strength of how much of the black area of the bar consumed the entire box. And so in this instance here, we're not getting that, because LVR, if we just look at the LVR is the loan to value ratio, and the loan to value ratio is kind of it's a continuous variable. So let's just take a look at LVR for a second. LVR is a value that's going to be, cannot be less than 0, because the value of the loan has to be something. And so it's the loan relative to the value of the property that's been acquired. In this instance, the mortgage is going to be advanced for a property, and the higher the loan to value, the more risky the loan is, because it means less equity in the home. So you can see here predominantly it's always less than 1. If it's in excess of 1, it means there's no equity. No deposit is being brought to bear in the purchase of the property. That means that the homeowner has really no skin in the game. Okay, so very often we want to see a loan to value ratio of maybe less than 80%. That would be a relatively conservative type of lending policy. What we might be interested here is to observe, is there any evidence to suggest that people who were non-white had a lower loan to value ratio being imposed. Okay, so let's take a look. Now this is for the entire data set, and you can see the machine learning algorithm, right, set out here, a decision tree. Perhaps we won't focus too much on the nuances here. We'll leave that to the next data set. But the main thing to observe really is that we have the loan to value, and we have these box plots that appear. It's not a 0-1 type situation. Here it's a continuous range of values. Unusual that we should get values too much higher than 1. That means the bank is taking on a lot of risk, right? If you don't have equity in your home, it means you've no skin in the game. You might walk, you might be prepared, more willing to hand over the keys of the home in the event of some kind of upset or trigger event. Okay, so in order to put that, so we turn off the graph, and then we'll invoke the deployer. So this is from the tidyverse suite. We invoke deployers. So this is for data transformation. We could take a look at our data. Looked at a little bit already. But you can see here that we have the different categories. With the loan to value, we have black deny. We're not going to use deny here, and we want to take this out of the data set. So for instance, we will filter out deny where it is no. In other words, okay, so if we take the entire data set, there was originally 2,380. If we run this again, and now we have accept, all accept, so those people that had more mortgages accepted, and then go to str, which is base R, and put in the all accept just to see what's in there, right? Let's just run. Then we now have 2,095, and basically only the people who So before we had individuals who were denied mortgages. Now we only have the people who were, their mortgage was approved. So yes, the individual was denied. No, means approved. So no success here. So just maybe look at that in the original data set, the HDM. Let's go into all, and let's look at denied. So denied is no, yes, so on. When we look at the newer data set, we shouldn't have any yeses. Okay, so we look at all except, there's no instance here of anybody being denied. Now, one other way I could have done that, if I had started off with this data set and then went to filter and then came here to deny and just said, okay, not denied, then you can see we have 2,095 entries. So the same as here. Okay, so it looks as if we have genuinely taken out those individuals whose mortgages were denied. Right? The mortgage approval was denied. Okay, so the all exceptions. So we want to build a C tree where the dependent variable now, we want to predict LVR, and the data set is just for those people whose mortgages were approved. So let's run that, and it appears here, and then we can take a look at it, right? But probably makes more sense to plot. And then just zoom. Okay, and then let's take a look at our data set here. So again, the objective, some degree prompted by the literature. A number of people have looked at this data set and say that there is evidence to suggest that there was discrimination on the basis of race here, and that was true with the DIR variable. That was true in some from the qualitative choice models that looks using Logat. That there does seem to be some evidence, although not maybe overwhelming evidence, but there's some evidence with the machine learning tree, a machine learning decision tree, C tree, set out by Halvarian. He suggests that the evidence isn't as compelling. Okay, so let's take a look here just to see, is loan to value, can we predict loan to value? If we have a lower loan to value for particular groups, it suggests that there's a demand for higher equity, and that might be suggestive of maybe some form of credit rationing. So when we start out, when we look at the DR, that payment to total income ratio, you can see here when it's quite low. So the lower it is, the better for underwriting purposes. Once it's quite low, means the individual mortgagor is less under stress, can more easily afford to service the payments. And there seems to be here in this instance quite a range of LVR. We see that by the interquartile range and the other values as well. When the DIR is quite high, that's less healthy type situation. And when we, in addition to that, if we couple that then with the mortgage credit score going from 1 to 4, where 1 is better and higher than 1 is less good. So in a situation where the credit quality of the individual is a bit better, if they're black, we see here that there's a higher LVR. Now there was an outlier here which suggestive that somebody got an LVR close to 2, but otherwise it's quite a bit higher on average. Well, the median value here looks quite high, and we have kind of a tight range here. Okay, if they're not black, then it seems to be lower, and that would be suggestive that actually a hard credit rationing policy is not being imposed. If the mortgage credit score is higher than 1, so less good credit history, and they are black again when we look at this variable for black, the LVR seems to be higher than for white. And this would be suggestive, again, that there isn't a hard credit rationing policy being imposed on a black cohort of the population.